Hi everybody, welcome to the CS50 quiz review. This is, we're closing in the semester, this is our final exam, and today we're going to talk about and give a high-level overview of the material that will be on the exam, going through the materials that we cover each week, and stopping for questions at the end of each week so that you guys can ask us anything that might come up during the week's material. Awesome, okay, so any information that you need about the quiz can be found at that link on the website. You will be taking the quiz in a 48-hour window between tomorrow at noon Tuesday and Thursday at noon. However, the quiz itself should not take you the full 48 hours. So for the test you had 72 hours and it was 10 questions, so you can expect for the quiz that it will be scaled down appropriately to allow you to work with enough time during that time frame. So again, you should require much less than 48 hours to complete the quiz. Again, release tomorrow at noon, due via Submit 50 on Thursday at noon. Be sure to run Update 50 in your ID before submitting, and make sure that you're not doing it within the final minutes before 12. So make sure that everything is ready and all set up for you to submit. Submitting 7 minutes late is equivalent to not submitting at all, as per our course policy. So again, don't wait until the last possible second. So what is going to be on the quiz? Any topic that we've covered in the course, essentially, you can expect to find that on the quiz. Regardless of that, the quiz will more so focus on week 6 through, are we on week 9?
9, yeah, 9, 10.
So through the last course material that we covered, and the focus will be on that, PSET 6 through PSET 8 inclusive. How to prepare. So again, consult the syllabus for the guide of topics. Make sure that you've gone over all topics through the syllabus and made a mental note of anything that will be on there. Review the lecture notes. Those can be found under the Weeks tab at the CS50 website. Review the lecture source code, so any source code that is used as examples throughout lecture, that is also available to you. Reviewing the lecture slides and rewatching lecture videos as you find useful, as well as reviewing the problem set specifications, distribution code, and sample solutions, which will be posted on the website online for you to view and refer to as well during the quiz. So office hours. Tonight we will be having office hours between 8 and 10 p.m. here, so right after the review session. There will be no office hours during the quiz. So tonight is essentially your chance to ask us some questions, ask the course staff some questions, and there will be no office hours indeed throughout the rest of the semester as well. Some other resources, you can post questions on CS50 Discourse throughout the end of the day today. Any questions posted afterward, our course staff will not answer, as well as any questions that are posted during the time frame of the quiz. Those will not be answered or addressed as well. And as with the test, the only humans to which you may turn for help are the course's heads. So myself, Brian, Doug, David, and Rob. And we will answer any logistical or clarification questions that you have, though we will not be giving away content that might be on the quiz. Final resources, so the quiz from fall 2016 is posted on the About section for this semester's quiz. Make sure that you go through all the questions, actually attempt the questions first before you look at the answers, and make sure that you actually walk through and figure out how you think about answering the question, and then refer to the answer, to adjust the way that you've thought about it, and ask us any questions tonight as well if you have about them. The tests from fall 2016 and from fall 2017, both are still available. For fall 2017, refer to David's email after the quiz, after the test, for the answers for it. And from fall 2016, that is also still available on the course website. Awesome. We have our CS50 quiz bank that can be found on quizbank.cs50.net that does not require a login and is basically a website that has a bunch of a lot of aggregated different questions on the course materials that we've covered, and you can browse through topics. old quiz questions from 2007 to 2015, and you can view both the questions and the answers. So if you're needing some additional practice and extra help, do refer to that resource as well.
One thing to know about the style of the questions on the quiz bank, the questions you'll find on the quiz bank are from back when the quizzes were like paper that were not take-home exams. And so generally speaking, those questions will be different in style. They'll still cover the same topics and same material, but if you're looking for questions that are going to be more representative of the types of stuff that you're going to see on the quiz, really best to look to last year's quiz, like Maria was mentioning earlier.
Yeah, exactly. So a lot of these questions might not be as concept heavy as the test and quiz have been, so definitely make sure to make that distinction when reviewing these answers as well. So week 0 through 5, for all of the material that was covered in those weeks, consult the test review session that was held back in October 16th, and the video slides, all of them are available under the Weeks tab on the CS50 website. Again, the quiz will have a heavier emphasis on the later content from week 6 onward, but all of the material remains fair game. So now we're going to shift into week 6, and Brian is going to talk to us a little bit about what we covered in dynamic programming.
Okay, so the rest of this is going to be spent on the topics from after week 5.
Yeah.
And the first new topic was dynamic programming. And if you remember from the dynamic programming lecture, this was the lecture that Benedict gave over at Yale. Dynamic programming is just really a fancy way of saying we're going to save the results of calculations we did before in order to be used later. And so this process is also called memoization, is a term you'll hear to refer to the same thing. And generally it means we'll solve smaller problems and store them inside of some sort of data structure, what we'll often call a lookup table. That way, as we go on to solve bigger problems, we can often define those bigger problems in terms of how we solved those smaller problems before. So if you attempted the more comfortable version of the similarities problem set, you'll remember that we were trying to figure out how much work would it take to convert one string into some other string. And in order to figure out how to do that, we asked simpler questions, like how do you convert this smaller string into this smaller string? And if you save the results of all of these previous calculations, that can make it more efficient then to do the calculation for solving the bigger problem in general. And the intuition there was that if in solving some big problem, you're repeating a lot of the same work. For example, if you remember from Benedict's lecture, we had the rod cutting example where there was a big long rod, and the question was like, what's the best way to break the rod up into pieces? And if you already solved the question of like, what's the best way to break up a rod that is 5 units long into pieces, then if you're trying to figure out, okay, how do you break up a rod that's 6 units long, you can solve it in terms of the problem you've already solved. You don't need to refigure out how to cut up a rod that's of length 5 if you remember it by storing it in that lookup table and then just reference it again when you need to use it again. And so there were a lot of different applications of it, from solving that rod cutting problem to comparing DNA sequences to figure out which is more similar to another, or looking at strings and figuring out how do you convert one string into another string. So a lot of different ways you can use dynamic programming, but the general idea that we were hoping you took away from that is that by saving the results of that early work in some sort of data structure, you can then use it later, and it's more efficient to do it that way. What questions do we have about that? Okay, we'll move on to week 6 continued, which was all about Python.
Awesome, yeah, so we introduced Python in week 6, and we made our big shift from C in the course at that point. Every single tool and fundamental that we learned and covered when we were learning C in the first few weeks remained very much relevant in our studies of Python, but again, the syntax just changed slightly, and we used slightly different terms to refer to the same thing. So we covered variables, conditionals, loops, and lists, all of those that were familiar from C, but with slightly less strict syntax, if I may say that. We covered tuples, dictionaries, objects, and classes. So tuples were very useful data structures that allowed us to pair two items together that might always go together. So for example, a student name and a student ID, as a very trivial example, might always go together, so you might put them in a tuple. Dictionaries were very useful when we had like keys and values that we might need to reference, and that allowed us to do a bit more than we could do with just lists in Python. And small note on lists. Lists in Python are essentially very similar to arrays in C, but in Python we call them more so lists, and we perform a lot of the similar actions that we could perform on arrays in C, but in Python and a bit more easily. And then objects and classes. So Python allowed us to implement and allows us to use objects and classes, which conceptually are similar to structs or structures in C, in that you have an object that has a number of different properties and methods, and all of those properties and methods apply specifically to that type of object. So you might have like an object of type student, and the student might again have a bunch of like different properties that are inherent to that student. So like an ID, a house, a year, and more so, and those are all properties of the objects. And then you might have some specific methods that you can specifically perform on students themselves. So maybe you can graduate a student, and that could be like a method that can be applied to that object, and any sort of like other things that specifically apply to students that you can think of. And that's why those were useful in Python. And a big thing about Python as well is that it's unlike differently from C, it's an interpreted language, so C was compiled. So the difference here is that in C we had to actually compile our programs using the utility called make, which utilizes Clang in order to be able to execute them. But in Python, we actually run an interpreter to consolidate that compilation step. So essentially, you didn't like have to make or compile your code when you ran your Python programs, but when you ran the Python program itself, runtime errors would come up, and that is like how you would know that maybe you've made a syntax error. With C, however, that was different, and you had to take care of all your syntax error before you were able to compile your code. If we can continue, awesome. Yeah, so one of the biggest changes from C to Python that we saw is that and as well as other more modern languages compared to C, is that it's essentially a higher level language in that it allows us to do a lot of the stuff that we had to like build from the ground up in C. Those are actually built into the language. So things that were like pretty complex, like when you all had to implement hash tables in C, they're actually already built in types in Python, and you can use any functionality that is built into Python as it is given to you. So you don't actually have to build things from the like ground up. And awesome. And what Python was useful for us was it was useful for web-based software. So in CS50 Finance, we used Python, and our ultimate goal was to do things like dynamically generate HTML. So we didn't actually want to have just a simple HTML page with hard-coded strings and values without being able to dynamically, based on the specific content that might be relevant to a specific user, we actually were able with Python to dynamically generate that, and when the web page was loading, to figure out what kind of like content we needed to be displayed, as opposed to needing to know that beforehand and hard coding it. And then we also, with Python, were able to respond to and process data passed via HTTP GET and POST requests. Those requests were slightly different in that POST requests were often associated with forms, whereas GET requests were simply associated with simply entering a URL and pressing enter. But those were very much and heavily used in our Python CS50 Finance P set. And then a lot of like other things that we were able to do is sort of abstract out common and repetitive aspects, so that whenever we want to like accomplish a different action in different parts of a program that you're building, you didn't repeat the code that you were writing, but you were actually bringing that code, that step, into the same place. Awesome. And the final big high-level overview thing that is important in our discussion of week 6 is the model view controller, our MVC. That's sort of like a paradigm that we have for how we organize the various aspects of a web application. So the model is the data on your site. So that's usually specifically like hidden from direct notification from the user, but users, whenever they interact with the model, they have to request for the data flow through the controller. And the controller is actually what you did in the CS50 set for finance and Python. You actually implemented all of your logic for how your website should behave and how your pages should react to user input. So every single decision-making process is part of the controller part of the model view controller. And then the view is essentially the looks and aesthetics of the page. So how the information is displayed, whether we're displaying the information in tables, whether we're displaying the information as a simple web page, as paragraphs, as text, all of that is controlled by the user. It's almost entirely in HTML, and the aesthetics are controlled also by CSS. So everything that the user sees. Awesome. I think this should cover week 6. Any questions so far on the week 6 material that we have? Okay.
Question?
Oh, yeah, question? How come it's considered not part of the model? Or? Yeah, so HTML is considered part of the view because with HTML you control what the different parts of your web page look like and how they're displayed. So with HTML specifically, you have initially a head tag and then a body tag, and then within your body tag you have this sort of hierarchical structure of saying, okay, I want to have a paragraph here, and then maybe I want to have a list here, and then a table underneath. So HTML controls using these tags. It's a markup language, so it doesn't actually allow you to perform any logical manipulations. We're going to talk about Jinja in a little bit, so that augments the capabilities that we have with HTML, but HTML is essentially marking up where the things in your website go. So that's why it's part of the view, not the model. It doesn't actually have to do with any processing of data and communication with your database. So the model is actually about communicating with your database and asking questions about pieces of data and then receiving back information about it.
So SQL then would be more so something that we would really classify as part of
the model. Yeah, so SQL is, yes, part of the model.
What model would we use HTML, JavaScript, and controller would be Python?
Yes. Awesome.
Yeah, and just to add on to what Maria was saying, the way you can think about it in terms of your CS50 finance application was that all of the information about what stocks different people own, that was all stored inside of your finance.db, your SQL database, and so that would be considered your model. And your HTML code that, yes, ultimately displayed how much of each stock that you own, does show you that information, but when you are writing index.html or quote.html, in that HTML code itself, you didn't include any of the raw numbers of the raw data. You just sort of designed the template or the view of what that page would look like, what the table would generally look like, and then it was up to your code to then connect that model and view together to say, okay, grab the data about what stocks I own out of the database and feed it into the HTML file such that then you can render a table that shows you all the stocks that you own, but all of that information fundamentally is stored inside of the database.
Yeah, exactly. So you were passing in, your HTML was saying, so stocks.price should go in this row of my table, and the stock name should go in this row or column. So it was saying where the data should go, but the actual data was being gotten using SQL statements, which we'll talk about also in a little bit.
Which of the presets would be best to review objects and classes in Python?
The problem sets themselves, so you're probably best going to want to turn to the lecture notes and lecture examples.
Yeah.
I think I remember in the first lecture when we introduced Python, David showed an example of rewriting the problem set 5 spell checker. And that was used using a object that would be used to check the spelling of different words in Python as opposed to in C, like you guys did in problem set 5. And so I think that would be a pretty good example of objects and classes in use.
Yeah, so definitely refer to, that's a very good example of David's reimplementation of the spell checker from C to Python that is implemented as an object itself. So you can definitely see like how the methods are part of the object itself and what properties there are and everything, how that works. Okay.
One more question?
Yeah, so JavaScript is also a controller?
So JavaScript can be used in a number of different ways. Most of the time that we've used JavaScript, at least in this class, has all been sort of client-side JavaScript used to interact with the view such that it was all running in your web browser, whether it's Safari or Chrome, and not really happening on the server. But Maria will talk a little bit more about JavaScript once we get to the later weeks.
Yeah. Thank you, Brian.
Other questions on that before we move on? Okay, so this transitions us pretty nicely into Flask. So Flask, if we remember, is a web micro framework. It's just some code that's been written for us in Python that makes it easy to write web applications using Python. It simplifies a lot of the process of handling a lot of the things that we would need to handle in order to build a web server. And so things it does for us, for example, are figuring out how to associate functions with different routes. And so if you remember, in a Flask application.py file, which is sort of the core Python file that controls your Flask application, you likely had a whole bunch of routes, where every route started with the @app.route sign, followed by some string that was like /by or /cell, or whatever that route was. Whatever that was specified, okay, what URL is going to be associated with the code you're about to write. And then underneath that app.route line, you had a function. And that function was associated with that route, such that whenever someone went to your finance website /quote, for example, that would trigger the running of your quote function, where you would then render the form that asked people to type in a stock, for example, or that actually went and looked up the stock, figured out what its price was, and then displayed an HTML form that contained the information for this stock costs this amount of money as of the current time. And so associating those routes with specific functions was an important feature that Flask gave us. It also gave us the ability in those routes to specify what request method we wanted to use in order to access that information. So Maria talked about GET requests and POST requests. Those were the two that we dealt with most commonly. And so if you recall, we could say if the request method was GET, in other words, if someone just typed in a URL and pressed enter, or went to your page and clicked on a link that took them to a different page, then here's the code that would run, like display a page that lets someone input the stock that they want to buy and how many shares of that stock that they want to buy. Whereas if someone then is on that form and says, okay, I want to buy 3 shares of Netflix stock and clicks buy, that's generally what we would call, or oftentimes, a post request, where we're sending some data to the server via the submission of a form. And as a result of that, your Flask application in that function can say, well, if the request method were post, then here's what we're going to do instead. We're going to figure out what stock did the user type in to the form. Let's go ahead and look up that stock, and then let's render some information as a result in order to figure out what the current price of that stock is and to make sure the user can afford it, so on and so forth. And so Flask allowed us to make that distinction between GET requests and POST requests and figure out what to do in one situation as opposed to another one. In addition to that, once we were able to do all of that logic in Python, Flask let us render these HTML pages that displayed the contents that we wanted to display. And in particular, we were rendering templates. It wasn't just that we were saying, here's an HTML page that I've already written, let's display that to the user. It was that our HTML pages sort of had these parameters, these variables that weren't defined at the time that you were writing the code, that you then filled in whenever something happened on your website, for example. So in your HTML page that you gave after someone types in a stock to look up in your /quote route, for example, you didn't know in advance at the time of writing your code how much a certain stock would be worth. You didn't even know what stock someone would try to look up. So what you probably did in your HTML file was parameterize it. And so here we used a separate language entirely called Jinja. And Jinja is a templating language, a language that lets us take HTML files and make them dynamic. Make it so that on the fly, while your application is running, it can generate custom HTML that will be used no matter who's using your website, no matter what stock they look up, no matter what the current price of the stock is. And so you'll probably recall those double curly braces that we would use in those .html files. That was all Jinja syntax, where the double curly braces generally meant like plug in some variable here. And then in your Flask code in application.py, when you wanted to render that HTML file, you would call the render template function, and so you would say return render template, followed by the name of the HTML file that you wanted to render, and then after that you would specify, okay, here are all of the variables and their values that I want to pass into the HTML file, so that the HTML file can then take those variables, plug them in wherever you had those double curly brace placeholders for them in the HTML file, and then dynamically generate the page that we wanted to display to the user. And so that's how we were able to create all of this custom content that we wanted to show to users based on some simple set of templates that we had already written using HTML and using Jinja. You'll remember that Jinja supports not only just substituting variables in by putting them in place where the double curly braces are, but we were also able to add logic to the Jinja files as well, adding things like for loops, for example. So we could say, let's loop over all of the shares of stock that a particular user owns, and for each stock that the user owns, let's put a row in that index.html table. And so Jinja allowed support for not only plugging in variables, but also doing logic with them. If statements if we wanted to, loops if we wanted to, the same types of things that you saw in Python. And in fact, a lot of the syntax of Jinja is very similar to the syntax that you saw in Python. There were just those additional curly braces and sometimes those quotation percent signs, rather, that we would use to say, this is Jinja-specific syntax that means I want to add a for loop here, for example, or add an if condition here, for instance. And so that was Jinja. And then one other thing that Flask allowed us to do was handle page redirection. So there are all these functions built into Flask, one of which is redirect, that lets us say, okay, at this point in the logic of my code, let's take the user to some other page, for example. So you probably use this when you were trying to register a user on your website, where after the user typed in their username and their password and typed in a confirmation password for when they wanted to register for your finance website, you would process that information, register the user using SQL, which we'll talk about in just a moment. And then after that, we're done registering. What do we do with the user? Well, you might have said, okay, let's redirect them back to the index page. So you might have said return redirect to whatever route you wanted to redirect the user to. And so Flask gave us easy access to all of these features and was a framework that included code for how to redirect, how to render a template, so that you didn't need to worry about low-level implementation details of how do you actually write that code yourself, and you could just use the tools that Flask gives you in order to produce those websites on your own. And Python decorators, the decorator is just a name for that @ app.route notation that we were using in order to associate the route that we wanted to use with the function that we wanted to call if someone went to that route. So anytime you were writing @app.route/by or /sell, for example, that was really just a Python decorator. And Python decorators are used for a lot more than just that. But in the case of what we've seen in CS50 and the work that we did with Flask, that's really all we were using decorators for, just to say, let's take this function and modify it to say, okay, this is the function that I want to run when a particular route is called upon. And so that was, generally speaking, what we were doing with Flask. It was sort of our way of writing Python code that would let us handle dynamic websites that accepted requests, processed those requests somehow, and then rendered HTML templates that somehow reflected whatever it is that we were computing in our Python code. What questions do we have about that? About Flask or Jinja or any of those topics? Yeah.
I have like 3 questions.
Sure.
My first question is, so login required above, like, that was certain portions of like the application. What is that considered to be? Is that also considered a decorator? What is that?
Yeah, so @login required is also considered a decorator. So you might have seen that atop a number of the functions that you had to implement, for example, buy, sell, among others. And the reason for that is that you need to have a user logged in order to be able to run these functions and perform the buying, the selling, the viewing of the portfolio. So we essentially built upon the functionality of the function that was built in order to say that when running this function, we need to have a user logged in. And if the user wasn't logged in, you might have gotten redirected when you were actually testing your web page and you stayed and you weren't active on your page for a while. You actually might have gotten redirected to the login page in that same way.
Yeah, so one way we could have solved that problem would have been to, if we didn't have the @login required decorator, we could have said, okay, for each one of the buy function and the sell function, the quote function. Let's just like add an if statement and check, is the user logged in? And if they're not logged in, redirect them to the login page.
Yeah.
But you might have noticed that if we did that, we would have been repeating a lot of code over and over, unnecessarily so, such that we would see the same beginning to all of our different functions. And so it was a little bit cleaner to say, let's write a separate function that would be a decorator called login required.
Yeah.
And if you actually go to, if you're curious, you can go to helpers.py in the finance application and take a look at the contents of login required. Really, it's just checking whether or not we've got a user logged in the session, and if not, redirecting them to the login page. And if we use that as a decorator, the decorator is just a way to modify a function, to give it some added behavior. And so if we put @login required above some buy function or sell function, that modifies that function to say, if the user is not logged in, then before even running the function, take them to the login page instead. Another question? Yeah.
Yeah, I have two more.
Go for it.
Okay, my second question was more so about how do you all think that like Jinja will be more so tested, more so like syntax based, or we all kind of like test whether or not we know how to like insert Jinja's like statements into our HTML, or like more so like understanding the way that the computer would process, or like the application would process the Jinja, or like
Yeah,
what Jinja is.
Yeah, in general, more so conceptual questions like some of the things you mentioned, like what Jinja is and like what the purpose of it is in our files. More so things like that will be tested as opposed to syntax, because syntax is something that you will be able to look up online. And obviously, we expect you to be able to, if we give you a small task that might be Jinja related, we expect you to be able to look that up, but and use it properly. But do like expect very like conceptual questions as well. So it's not going to be just syntax based and like inserting like things and stuff like that if you are tested on Jinja.
Do you have one more question, do you say? Or is that it?
I did, it was mostly related to web applications, but I think that kind of was like, I kind of maybe touched on a bit, asking more so like how would you think web applications would be tested? And I think that is.
Do you have a question? Great question. The question is Jinja something that's run client-side or server-side? Ultimately, it's all your Python code, so that's all stuff that your server is handling.
Yeah.
And so if you had like an error in your Jinja syntax or something, or a variable that wasn't defined properly, you might have run into like an internal server error in your Flask application, which should clue you into like, oh, this is a problem with what's happening with the server of your code. So what's ultimately happening, if you're curious, is that the render template function is a function that's running on your web server, the Flask web server. It generates the HTML code that you want to process, and then that HTML code is sent from your server to your user who's using it on their web browser, and then the web browser on the client side just displays the contents of that HTML page. But great question. Other things about Flask? Okay. With that, we'll move into week 8, and week 8 was all about databases, and in particular about SQL, or SQL, which stands for Structured Query Language. And what SQL was, it was a language that let us make requests and talk to databases. And so it is actually a programming language. It's a different sort of language. But SQL itself is not a database. It's just a language for interacting with the database. And there are a whole bunch of different types of databases that use SQL as its language. So common ones are MySQL or PostgreSQL, and the one that we were using is called SQLite. And that's why if on the command line you wanted to edit your database, you might have typed SQLite 3 as the command to get into that database. So we were using SQLite databases, which is just a database format that speaks this SQL programming language that can understand those requests and respond to them. And so SQL databases in particular are relational databases. And the best analogy to think about for relational databases is just to imagine like a big spreadsheet, where we have columns just like spreadsheets do. And so for all the data we wanted, we had to first create the table and specify what the columns we wanted were. And so if you remember the example from lecture where we had like registrants for Frosh IMs, we would have like a column for the user's name, a column for their email address, a column for their dorm, for example. Any of the fields of data that we wanted, we would have to specify what columns we wanted for that. And then for each entry of data in that database, for each person that we wanted to register for Frosh IMs, for example, that was an additional row inside of that table. And so the syntax and the notation is the same when it comes towards SQL. We still have tables. Those tables have columns, and we have rows or entries in those tables that correspond to data that we have stored inside of that database. And the most common operations that we wanted to do with those databases are to create, read, update, and delete data. And we did that through a variety of different SQL queries that we'll take a look at in a moment. Did I miss something? Okay. So in terms of SQL syntax, the 4 main commands we were using in order to interact with the table were select queries, insert queries, update queries, and delete queries. So the select query was really our way of getting information out of a table. So we already had a table, we've got a whole bunch of data there, and we want to extract information out of it to find out, for this current user, what is their password hash? Or for this current user, what stocks do they own? To answer questions like that, where the answer is in the database, and we just want to figure out what the answer actually is. And so the general syntax for a select query is to say select followed by the columns that you want to extract, the columns that you care about getting the data for. If there's only one column, you could just use the column's name. If there were more than one column, like you see above here, you can use commas to separate, okay, here's column 1 that I want to get, and here's column 2 that I want to get. And if you want to get all of the columns, if you want to get all the data for any particular row, you can use the star symbol. Select star just means select all of the columns for the rows that you're trying to get. From table name just says, okay, which table are you selecting the data from? Remember, your SQLite database doesn't necessarily just have one table. Maybe you've got one table that's keeping track of all of your users, but you've got another table that's keeping track of your portfolio and all the stocks that people own. So your database probably has more than one table, and so when you're selecting, you need to tell the database, this is the table name that I want to select my data from. And then finally, we have this where condition that says, all right, I obviously don't want to select all of my data in most of the cases. It's generally the case that if I've got a database that's got all of the data for all the stocks that all of my users own, I'm really only concerned with getting the stocks that I own or the stocks that Maria owns, for example. And so the where condition is a way for me to specify which rows do I want to select out of the database. So I could maybe only select the rows where the ID is equal to whatever my ID is, or only select the rows where the stock symbol is Netflix to get me all the people that own Netflix stock, for example. And so the where condition can be used to say, these are the only types of rows that I care about selecting, and that will only get me that data. So that was useful when you had different users logged in and you had to only get information pertaining to the user that was currently logged in. On the flip side of things, if you didn't want to just get data out of your table, but you wanted to add data to your table, that was where your insert query probably came in. And so the general syntax for an insert query is to say, let's insert into a particular table, and then specify which columns you wanted to insert data for. And so some of your columns might have been auto-populated. You might remember that when you design your table, you can give columns a default value. So if, for example, you wanted to keep track of the time of the purchase of a stock, for example, you could have, when you created your table, specified, all right, let's add this column for keeping track of the time, but let's set its default value to be whatever the current time is, for example. And then when you were adding data into the table, you didn't need to worry about adding something in for the current timestamp, for example, because your database would handle automatically just defaulting its value to the current timestamp. Likewise, with each user's ID, you likely didn't need to worry about when you were registering users of inserting an ID value into it, because our ID value is automatically given to us, generated for us. It's automatically increments, which we'll talk about in a moment, and so you didn't have to worry about inserting that. But whatever data you did want to insert, you would have to specify in the insert query what the names of those columns that you were inserting data for were, and then follow that up by saying, okay, what are the values for those columns that we actually want to insert into the database? So maybe you were inserting a username and their password hash, and that was the columns that you wanted to insert. And what would those values be? It would be whatever their username actually is, and then whatever the result of taking their password and hashing it was. And that might be what you would insert into the database that way. So that was the insert queries. And if we had data in the database and we wanted to change that data in the database for some reason, that would be where an update query comes in. And so an update query looks pretty similar in spirit to the last two. You can generally get a sense for the fact that SQL queries can oftentimes be read like English. It's like, select these columns from this table where that condition is true. So you can sort of read it out loud and it makes sense as to what it means. Update queries are much the same. I can say, update this particular table. Let's set this column to have this value where some condition is true. If you didn't have that where some condition is true, you would be setting all of the rows to have this value for a particular column, which probably isn't what you want. You generally want to update only the rows that you care about updating, and you'll specify that the same way in the select query you do by specifying only update this table for rows where a particular condition is true, where ID is equal to 28 or whatever the user's ID happens to be. And then finally, if you wanted to delete rows from a table, the syntax for that is even simpler. It's just delete from whatever the name of the table is, where, and then followed by some condition. Again, without that where, delete from table name would just delete all of the rows in your table because SQL doesn't know which rows you want, so it just assumes you want all of them. But where condition lets us say only delete these rows if this particular thing happens to be true, and that lets us specify which rows in particular we want to delete. So generally speaking, those were the types of queries we were doing. You may have also done like create table queries. Those were another type of query you can do if you want a brand new table to be added to your database as well. There were other pieces of SQLite syntax that we talked about involved with this. One was primary key. Primary key is something we can specify for a particular column to say that like this is the main way by which we're going to be referencing rows in this table. And so in our case, for like our users table, the ID column was our primary key. Every user had a distinct ID. No two people had the same ID. And that was our way of identifying one user compared to another.
Yeah.
Do you have something to add there?
Yeah. So something that that I noticed in a number of people is that in your users table, you might have wanted to say your primary key to be the ID, but you might not have wanted that to be true in, for example, the transactions table that you have. And so if you did set your the user ID to be the primary key in the transactions table, then you might have noticed an error where whenever you're trying to make a new transaction, you actually cannot insert a new row for that same ID, because if the ID is the primary key, you cannot insert any more rows for that same user again. So just jumping off and saying how that might come up.
Yep. Relatedly, a keyword can be unique. You can specify a column to be unique to mean that you only want unique values for that column. For example, you might use that in a user's database where if your ID is your primary key, maybe your username isn't your primary key because you really only have one primary key for each table. But maybe you still want your username to be a unique field because you don't want two different users to be able to have the same username, for example. Whereas it wouldn't make a whole lot of sense for like cash to be a unique field because it's totally possible that two different users might have the same amount of cash, for instance. And so you wouldn't want that to be a unique constraint for your table. Not null is another property you can assign to a column that just says that this column needs to have a value. And so sometimes you might have situations in which a column might not have a value and you can just have null or nothing there as a value. If you want it so that whatever row you insert into the table needs to have a value for this column for one reason or another, you can specify that column to be not null. Auto increment is another property you can assign to columns to say that you want for every subsequent row you add to the table, its value should automatically add 1 to the previous value. And so we use this for our IDs, where our IDs were auto-incrementing fields, where when the first user registered for your finance website, they got ID number 1. And when the next user registered for your finance website, they got ID number 2. And the reason why that happened is because our ID column of the users table was an auto-incrementing field, an auto-incrementing column, such that every time we added a new user into that database, that value would increase by 1 as a result.
And that's why you specifically didn't have to actually insert a new ID for, and a new value for the ID in any insert statements that you had in your pset.
Exactly. And then final piece of syntax we'll talk about is the foreign key syntax. The foreign key was just a way of representing the fact that one table might be related to some other table, and to express that relationship between two tables. So if, for example, you remember the example from lecture where we had a whole bunch of like albums and artists, and we had a big database with music-related data, where every album had a artist who's the artist of that album, and we had a separate table that had all of the artists. And so we might have had a foreign key inside of our table of albums to say, you know, this column that's called artist ID, this is going to be a foreign key that references the ID of the table of all of our artists. So the foreign key just means it's a way of relating one table to another table and saying that the data in this column of my album table is going to be referencing the data in the artist table and whatever their ID was, because every album has an artist. Questions on SQL syntax so far? Yeah.
So primary key and unique, they're both, in a sense, they're both unique, but there's only one thing that could be called a primary key. Like, what's the difference between them?
Yeah, so you touched on one difference, which is that there can only be one primary key, but multiple different columns could hypothetically be unique. The primary key, generally speaking, is, as the word primary suggests, like the main way by which we're going to be referencing some piece of data. So in the case of users, for example, the main way by which we access a particular user is based on their ID, right? Oftentimes in your SQL queries, you would say, you know, select from whatever table you were using to store stocks where the user's ID is equal to this ID for the user ID. And so in terms of how these databases are actually implemented, databases can be a little bit fancy about making sure that they can optimize for how you're going to use it. If you're going to be referencing data by the primary key a lot, then your database can structure itself in a way such that it's fast to be able to access a user based on their ID. You, as the person working with the database and writing the queries, never had to worry about that at all. But in terms of the design of the database itself, it can make some optimizations to try and account for how you commonly are referencing or using that data. Yeah?
Doesn't it automatically make the primary key unique? Like, say you like specifically went in and tried to change it, like the primary key, would it let you like have it a value that another user has?
The database would not let you set it to something that another user had. You could probably change it to like an arbitrary number that wasn't already in place.
Yeah.
But yeah, the database does enforce the constraints about like these columns are unique, for example, and won't let you break those constraints.
Yeah.
Yeah, question back there?
So just conceptually speaking, within lecture, Professor Malin mentioned that CSVs are bad for storing data because they have such ridiculously long lookup times. Is that problem solved when we use SQL or not?
Generally speaking, it's better. And so the reason why it's better is you can imagine that the database is doing work for you to help make querying more efficient. So in the CSV file, if we wanted to look for a user that has a particular ID, we might have to like open up the file and look through every row, one row at a time, looking for some user that's got a particular ID. Whereas in your database, if you say, okay, ID is going to be my primary key, your database can optimize itself in ways that you don't need to worry about how it does it. You just need to know that when you then query for like get the user that has this ID, the database can be a bit faster with that.
Yeah.
And so the SQL database structure does allow us a lot of speed ups in terms of runtime improvements over just processing like a text file like a CSV.
Yes.
But if we now have like two questions, so then comparatively speaking, would it take up the same amount of space if it were like on an actual like computer? Or because it's an online like sort of SaaS type of thing, it doesn't matter?
In terms of space, the space that some kind of information would take on your computer should generally be equivalent to the space that it would take on a remote server. Is there like another concern in there, or just understanding whether there's a difference?
Yeah, it was more so like kind of referring back to like the actual Excel files versus this in terms of space is better. So you're saying that this is faster, but then in terms of space, or is that not? If it's not relevant to like the class and like idea kind of thing.
Yeah, space-wise, there shouldn't be any like.
They'll likely
major
be
differences.
similar.
Yeah.
But I would imagine that because we are storing in a database,
Yeah.
there's probably some overhead that database has that just somewhere in your database file, you've got to encode, the name of the table and the structure of what all the columns are and what types of data all of those columns are. And so that's all data that's got to get stored inside the database as well. And so if you're just storing, like a couple rows, you might notice that the database has got a little bit of extra memory in order to, store the overhead required to build the database. But in terms of the data itself, that could be the same across both.
Yeah, the data itself is the same across both, but again, like you'll notice that a lot of big companies like Google, Facebook, they use databases because the trade-off of being able to get information a bit more quickly is as their rows and their users become in the millions and billions, that that trade-off becomes very, very apparent, because storing the information about the headers and the actual information about the table itself, as Brian mentioned, that isn't necessarily something that given that big of a scale would be relevant.
Great questions. Other things? Yeah.
Should we explain what db execute select returns and how to reference the elements inside this list?
Yep, great question. So the question is, what does db.execute actually return when you run a select query on it? Ultimately, what it will return is it will return, in Python at least, a list of all of the rows that matched your select query. And those rows themselves are represented as Python dictionaries. So Maria mentioned how dictionaries have keys and values. In the case of our rows, those keys are the names of all of the columns, and their values are whatever that row's actual value was for that column. And so if you ran a select query to get the amount of cache that a user has, for example, you might have gotten back a list of all of the matching rows. Maybe there was only one matching row, though, so you would have to say, okay, square bracket 0 to say the first row. And then within that row, you might do square bracket name of some particular column to get the value of that particular column. So list of rows, each row has keys and values where the keys are the column names. And if you do square bracket column name, you end up getting the value for that column for that particular row.
Yeah, that's a good distinction to make, just because what db.execute will return is it will return a list, and you typically might have indexed into the list using square brackets index 0. That is indexing into the list, but then as Brian mentioned, using the square brackets again, then you're actually getting the value for that specific key that you're putting into the square brackets.
Of course, you want to be careful, because anytime you're doing square bracket 0 or square bracket anything for a list, if nothing returned back from the database, if it were just an empty list that was given back to you, if you try and do square bracket 0, Python's going to throw an index error at you, because there is no 0th element of the list. And so either checking for that or handling that somehow would probably be a good design to be thinking about as you go about writing those.
Yeah, making sure you don't go beyond the bounds of how big your list is. Or other questions? Yes.
I remember the piece set where we kind of treated it as the db.execute select. We kind of treated it as a Boolean. So, for example, if we tried to select a row in the database that did not exist, what would db.execute return?
It would return an empty list. So if you selected something and there were no rows that matched something, if I said select from users where ID equals 1,000 and there is no user number 1,000, then that query is just going to give me back an empty list, because there were no matching rows that matched the query. And so the reason we can use that in an if statement, like a Boolean expression, is because in Python, the way if statements are processed is that there are some values that are considered to be false. And so you could literally say false if something evaluates to the Boolean value false, that's false. But in terms of an if statement, an empty list is equivalently a false value. And so if I said if some list, and that list has nothing in it, that would be considered false by Python's interpreter, and then that code wouldn't run, for example.
Yeah, so we're not returning a special value, but it would be empty, and that would be considered as false. Yes? Or
Other questions about this?
yeah.
Slight syntax question about the db.execute return. So are you saying that means that we can kind of index into your return by going to 0 and then the actual element name by using the quotes, right? So then if we want to go into the next key set, right? And it's if with list, or no list with or a mix of lists inside of it?
List with dictionaries
Yeah.
inside of it.
So it's a list, the dictionary inside of it, just made up like key and the element, right?
Yes.
So then if we wanted to get the next key element set, do we still use the, like, or do we still use square bracket 0? Or do we square bracket like 1?
So depends if you want to get for the next row, so for the next like entry in your table, the next maybe user, then you would need to go one index further into the list. So if you wanted to stay at the same list, at the same user, and you wanted to maybe not get their cache, but get their name, for example, or username, then you would still remain at index 0, and you would change the key in which you're with which you're indexing into the dictionary. So you wouldn't index into cache, but you wouldn't get the value for cache, but you would get the value for username. However, if you wanted to like go to the next user and get values for them, then you would need to like update the values in with which you're indexing. So that's 0.
So when on key set, the reason we were always using 0 is because this person was logged in by a specific ID.
Yeah. So the reason why we were using 0 is that we were expecting that the ID was unique, so we would only get one row returned.
So if we
Yeah.
were to actually use another number in 0, it would like return an error, and which we all said earlier, like I think you said was like a false value.
Yeah, if you had tried to access like square bracket 1 or square bracket 2 of a list that only has one element,
Yeah.
that in Python is what we call like an index error, because you're trying to index into a list, get a particular element out of that list, but that index doesn't exist. There is no
Yeah.
list element 2, for
Yeah.
example.
So then within like the case of our like recent Prosecco with like the Google like Maps one, when we were like getting the articles before JSON, like we only wanted to like limit it to like a certain number or whatever. Then would we would it have been like okay to utilize 1 or 0, 1, 2, 3 then? Since
So the question was about this past problem set and whether you could, if you were trying to limit to only like 3 things, can you just do like 0, 1, 2? That would be fine if you were sure that there were at least 3 rows in whatever you were getting back. If there was any chance that like no news articles would be returned or something like an empty list or something, you would want to be careful about indexing into any particular value. Generally speaking, whether it's about this past problem set or finance or any of them, anytime you're indexing into a list, you want to be sure that whatever number you're indexing into actually exists, or otherwise be ready to handle whatever goes wrong if it doesn't
Yeah.
exist.
Do we have any other questions?
Okay, we'll move on to a couple of other last things about SQL. So with SQLite databases, there were a couple ways we could actually interact with it. One was directly with our Python code. We could use db.execute followed by a SQL query, and we could run that using Python. If we didn't want to do that through Python, we could have used the command line. We could have typed SQLite 3 followed by the name of the database, and then we could execute queries that way. Alternatively, though, if we wanted a more graphical way of interacting with it, we took a look at PHP Lightadmin, which you could get to just by double-clicking on that database file inside of CS50 IDE. And that opens up a graphical way to type in SQL queries, to browse all the different data that you have, to create different types of tables. So it's a web-based tool for helping to manage manage your database via a nicer-looking user interface that lets you do things like look at all your data and insert data. And recall that when you were creating new tables, PHP Lightadmin also prompted you to like pick what's the type of each one of those columns. And you have to figure out, okay, is this column going to be an integer? Is this column going to be a text column, or what type of value are you going to use to store there? And that was where a lot of important design decisions came in. Like, okay, with zip codes, it might seem like you would want to store zip codes as a number, because zip codes are a number. But in actuality, for like Cambridge, where the zip code is 02138, you have to be careful, because if you represent 02138 as a number, it's going to show up as 2138, because the 0 gets chopped off. And so in that case, it might have made more sense to store the zip code as a text field instead, for example. So all of those design decisions came about as we were trying to figure out, how do you create tables, what are our columns going to be, and what types are we going to use to represent all of the data in those columns. Okay. Last thing I think on SQL was figuring out how to join different tables together, which we talked about briefly in class. And so this became relevant when we had different tables that were trying to reference the same information, or that somehow were connected in some way, whether it was your portfolio table that somehow referenced your user table, or whether it was our album table somehow referencing our artist table in the example that we saw in lecture. And so the syntax, which we saw briefly for how to join those tables together, looked something like this. Select from album, join the album table with the artist table, and you need to sort of tell the database, okay, if we're joining these tables together, how are these tables connected? How are they related to each other? And so we say we're going to join these tables, and here's how they're related. The artist ID column of the album table is going to be the same as the artist ID column of the artist table, to say that we just match up the album's artist with the ID in that artist's table. And by doing that, we were able to create a table that showed us all of this information sort of joined together all at once. And so joining tables was our way of taking two different tables that all the information factored out in different places and put them together in one place where we can see all of the information we care about at the same time with just a single query. Final questions about SQL or databases? Otherwise, we'll move ahead and dive into JavaScript. All right.
Okay, great.
Sorry. One more thing about SQL. One thing you have to be careful about when it comes to SQL and databases in general is security, and what could go wrong as you go about thinking about databases and inserting information into databases. And one security concern we talked about were SQL injection attacks. And so injection attacks are when someone tries to exploit your website, your web server, by maybe typing something into a form that looks sort of like a SQL query or part of a SQL query in order to try and trick your server into running SQL commands or SQL code that you, the user, the malicious user using the website, tried to write, as opposed to only running SQL commands that the server wrote. And so you can see examples of this in the lecture where in like a username and password field, if you're tricky about the type of thing you inserted into the password field and the server is not implemented very well, you can like trick the server into running whatever SQL code that you want. And so for that reason, we had to be careful when we were running code about making sure that our SQL statements were run in such a way that were secure and that were not vulnerable to SQL injection attacks. So if in your db.execute queries you notice syntax like your colon something, just mean like placeholder for something here, and then you passed in as arguments to the db.execute function additional values that you wanted to go into the query, that was our way of defending ourselves against SQL injection, because the db.execute method would take care of saying, let's make sure we avoid SQL injection, and let's escape characters by ensuring that none of the stuff that a user typed into a forum is ever going to get run as actual SQL code. And so that would be the secure way to do it. In contrast, if we were to just say like use like formatted strings to just plug in whatever the user typed in blindly without worrying about like what actually they typed in, then we might run into a situation where we might accidentally run SQL code that the user wrote rather than SQL code that you yourself wrote, and that leaves yourself open to the possibility of this type of attack. So just always good to be mindful about what the security implications of things are, to think about how things might go wrong. And with SQL, this is one way that things could easily go wrong that we can defend against using common sense measures by making sure that we escape any potentially unsafe code. Yeah?
When you say escape, like potentially unsafe code, is it just like doing the colon thing?
For the purposes of what we saw in the class and with the problem set, yeah, when we did the colon syntax and followed by the variable you wanted to pass in, that was sufficient for your purposes because the db.execute method behind the scenes took care of actually doing the escaping. And when I say escaping, the simplest example to use is like, if you remember from like way back in C or even in Python, like \n was our way of saying like new line. And if I tried to print out \n, that would, rather than printing out the characters \n, would just literally print a new line. So that \n character was like special syntax that did something special in printf. Likewise, we wouldn't want for the user to be able to run like special SQL commands just by trying to run the code on whatever input that a user had typed into a form, for example. And so by escaping it, in the case of \n, we would like add another backslash to mean like \n would literally print out \n instead of printing out a new line. There are similar things that we can do in SQL. You don't need to worry about exactly what steps to take in order to escape the SQL statement, but just know that we modify what the user types in somehow to make sure that whatever they do type in doesn't get executed as actual SQL commands.
Okay, and then CS50.SQL.execute would like do the backslash.
Right,
Yeah,
exactly.
db.execute escapes for you.
On the most recent case set, there was like a part of the code where we were trying to optimize the search box so that the users could put in different types of inputs, and we did that into db.execute. So I was just wondering if there was like a better way to go about that other than like doing for different inputs and like trying to concatenate different strings.
So there were a lot of different ways to go about that particular aspect of the problem. Certainly, a good strategy would have been to, at minimum, try and match on like the beginning of a city name, as opposed to requiring that you type in all of Cambridge. Like if I type CAM, hopefully you can write a query that gets me all of the cities that start with CAM. By you may have seen in the problem specification, the % can be used as like a placeholder for saying, find me all the cities that are like this, that look sort of like CAM followed by something else. And so that would be a way to get those cities that match that. But ultimately, there wasn't one particular, like, this is how you should be searching for cities that we were looking for, because there are so many different columns and different ways to go about searching it. We were sort of leaving it up to you to be creative about how you want to go about searching and what types of search queries you want to support.
Cool. Yes.
So is there like equivalent for sanitizing inputs for like Python command line language, or if we
Sorry, did not hear that.
Okay, the question was, do we need to worry about sanitizing arguments if we're just taking an input? Generally speaking, you only need to worry about sanitizing arguments if you're ever taking input that the user gives you and using it as part of like code you are actually running. So we had to worry about this in the case of SQL because whatever input that they give us, if they say their username is this or they're looking for Netflix stock, we took Netflix, what they typed in, and plugged it into our SQL query and said, like, find me all of the stocks whose symbol is Netflix, for example. Yeah. And we literally plugged in what they typed in into the query. That's the type of situation when we need to be careful about sanitizing inputs and making sure that we're not vulnerable to injection, because we plugged it in, and if they had tried to do something malicious there, we've just tried to run a SQL statement that they could have written. If all you're doing is, like in your Caesar program, which you may have rewritten in Python, is like take in input and then iterate over that input and modify the characters, you're never actually like trying to run the code that the user typed in. And so in that case, we didn't need to worry about like sanitizing what the user typed in. Great question, though.
Yeah. Okay.
Okay, I'll turn it over to JavaScript now.
Awesome. Yeah. So JavaScript, that's the next language that we went over. All of our tools, all of the fundamentals that we covered again remained the same, but slightly different syntax. So we covered variables, conditionals. So the conditional statements this time may have looked like slightly bit similar to C again. The curly braces came back, and the semicolons at the end of the lines like also came back. Our loops that we saw in C and in Python we were able to use again. With JavaScript, we were also able to use the typical for loops that we saw in C, in addition to the like for loops, the types of for loops that we used in Python as well, in terms of iterating over the specific objects within a certain data structure, like a list. We had arrays and we had objects again. Objects, just like in Python, we're able to have methods, properties, and all of these things that we saw and were relevant as well as in the previous chapters. And a big thing in JavaScript as well is that we could have anonymous functions. That meant that functions didn't specifically need to be given a name. And this is really interesting because it stems from the fact that functions essentially function as values, or can be used as values in JavaScript as well as in Python. So that means that you can pass around functions just like any other object, just like any other data type that we've seen in JavaScript, and you can assign variables to functions to variables. So like you can have a variable that actually stores a function, so you can do you can pass around functions just like values. And that allowed us to also have these anonymous functions, meaning that if a function didn't need to be given a name, for some reason, if we were potentially returning a function from within a function and weren't using that internal function anywhere else again, then we might think that sort of like naming that function would kind of be wasteful. That's why the purpose of anonymous function and the concept of anonymous functions is that we can define a function that takes in some input and maybe returns some other output as well, and does anything that a regular function would do within its own function body, but just meant that we didn't necessarily have to give functions a name. And in JavaScript, we also got introduced to events and event handlers. So events in JavaScript, as we saw, can be things like clicks, hovering, any user interactions with any specific element or part of a web page. And whenever sort of a user performed any such actions, we could listen for those actions. And we could sort of wait for those actions to happen. And that's called an event handler. The event handlers are listeners. They're functions that are executed in response to some event, to something happening on our website. So again, like mouse clicks, key presses, form submissions. So essentially, you have a function that's waiting, that's listening for this event to happen. It gets the signal, it gets like sort of like the call to itself whenever that event happens, and then any like thing that is within the function body gets executed. And then these handlers tend to be anonymous functions, which is where the idea of anonymous functions like becomes like very useful as well. So you might have a function that you only want to execute when a certain element from your web page is clicked. So whenever a certain button is clicked, for example, to submit a form, then you might want to run a function that handles whatever happens after you've submitted that form. And any sort of function that is an event handler doesn't need to be given a name, but it can sort of run. And we can refer to the specific syntax of this within the pset 8 and the solutions as well. But we didn't actually have to say that like the function didn't actually have to be given a name, but we just needed to say this is a function, and like we had to give the parameters that the function was taking. And in JavaScript, we use the function keyword, unlike in Python, we use the def keyword, so similar, but yes. And then a similar concept we have as well with JavaScript are callbacks. These are functions that that get called whenever something else has finished running. So the similar concept that we saw in pset 8 is that, and that Brian is also going to talk about as well with Ajax in a little bit, but we had we wanted to get some data in order to be able to display like a number of articles for a specific place. And what we actually did is that we actually made the call to the server to get us this data. We asked for the data, we asked for the articles, and while waiting for the articles to perform, we could continue on doing something else, but still have our function definition there with our anonymous function defined to perform something whenever something else is finished running, and that something else in this case would have been the fetching or the gathering of the data. So whenever our data was actually like finished, it was ready for us to use, then we could run our anonymous function and perform every single thing that we wanted to perform with that data. And this is a super, super useful concept. Brian is going to get into a little bit more detail about this as well, but it is very, very useful because it allows us to sort of not block anything that is happening on our web page while we're waiting for some kind of like data to load. For example, you might be waiting for a lot of your photos to be fetched from an app that you're using for like photo storage. And what like the people who implement this software do is that they don't actually block you from doing anything else. They don't block any like other lines afterwards from executing, but they wait on the data to be fetched and then use the concept of callbacks to perform any other actions after that data is already available. Do we have the next slide? Thank you. And so in writing JavaScript, we saw that one way that we can include JavaScript, we can include it in HTML directly using script tags. So whenever you were to open a script tag and then close a script tag, anything that you put in between can be JavaScript, and that can run in the specific HTML page that you're building and that you're writing. A trade-off of this is that we could also actually write JavaScript in .js files as well, so separate files. And one thing to note here is that there's obviously like advantages and disadvantages of either technique, but one thing to consider is that if you have a lot of like different HTML files for displaying a lot of like different pages on your web application, you might not want to copy over the same exact JavaScript code into all of your pages, and then again have to, if you want to change something small, then you would maybe have to go through each HTML page and go through the script tags and like change everything in the same place. But instead, you could actually write your .js file and then include that file in any HTML page that might use it. And then you would actually be able maybe to edit the JavaScript within the full file itself, and it might apply to different HTML pages. So again, this is sort of in general going back to a lot of the different paradigms that we've talked about, not repeating code whenever we write it, but actually like reusing code with the concept of functions and a lot of other things that we mentioned today. Another thing that we talked about with JavaScript is the document object model. And if you go back to week 6, you'll see basically that the HTML page, again, allows for websites to be viewed as sort of like this hierarchical structure as a tree. And in JavaScript, what we actually get is an object that represents an HTML page, a web page. And that's called the document object. And going down hierarchically, like bubbling down, starting from the object, going into the actual HTML, the head, the body, and then all the specific elements, we could sort of specifically find any elements that we wanted to modify, directly manipulate the elements, and like manipulate like different aspects of those elements, maybe the way that they look, maybe the content that they contain, so that you could change your site on the fly and retrieve new information that the user might have requested on the fly without actually needing to reload a web page. And that's what was so powerful about JavaScript, and what Brian is going to talk about in a little bit is that JavaScript allows us to not, unlike CS50 finance, where somebody, for example, had to, if they were selling a stock and they only had 4 shares of it, but they were trying to sell 6 shares, they actually had to press a button and be redirected to one of the apology templates saying you don't have enough stock of this to sell. What JavaScript is going to allow us, as we saw with Mashup, is to do this error validation on the fly without actually needing to reload another web page. So we're going to be able to respond to user interactions and to users entering new information and interacting with our web page by dynamically either modifying elements of the HTML, making some elements appear, adding elements, deleting elements, and a lot of different capabilities that come from the use of this document object. Cool.
Okay. So as Maria was alluding to, we'll talk a little bit about AJAX now. So AJAX is a technology. It stands for Asynchronous JavaScript and XML, but nowadays we'll mostly use JSON, JavaScript Object Notation. But generally speaking, what AJAX is it is a technology that lets us make asynchronous requests to get additional information for a page. So user clicks on a website, they've loaded the website on their computer, and normally, in order to get more information, you might imagine they'd have to click on a button that takes them to an entirely different page to render a new page. But what AJAX allows us to do is it lets us make asynchronous requests while the user is still on the page, let them continue interacting with the page while your web browser is trying to retrieve and access more data from the web server. And then when it gets that data back from the web server, it can do something interesting with it. So examples of this that we saw were in the mashup problem set that you guys just completed. When you typed in a city into your search bar at the top of your web page, it wasn't that your web page already had downloaded into it a list of all of the different cities in the entire United States. That would have taken a whole lot of time to send from the server to your computer. Rather, instead what was happening is you typed in like CAM for Cambridge, and then what happened next was that that query was sent as an AJAX request. We made an asynchronous request to the web server to your /search route in application.py, ask the server for more information, in particular asking it, get me back all the cities that start with the letter CAM. It gave you back that information, and then your website was able to update by updating that drop-down list that you saw as a result of that search in order to reflect the results of that additional information that you were asking for from the server. So it wasn't information that was already in your web page, but when you typed in something, when you did something to the web page, you sent an asynchronous request to get more information, and then you got it back. We saw other examples of this when you tried to drag around in Google Maps. When Google Maps loads in your web browser, it's not loading the entire map of the entire world, but as you drag around, Google Maps is making asynchronous requests to the server asking for more map data, and when it gets that map data, it fills in the map. And then finally, the other example we saw was with your articles, that when you clicked on a marker, what happened was that the articles weren't already on your website. We had to make an asynchronous request to go get you some more articles, get the information for articles about this location, and once we got that article information, then we could display it inside of that, the information window that pops up after you click on a particular marker. And so those are all examples of AJAX requests and how they prove to be useful, because it lets us keep users on the same page, but still update the content that they see in order to reflect how the user is interacting with the web page. So it creates for a better, more enjoyable user interface from the perspective of the person using the web application, because they don't need to click around to a whole bunch of different pages in order to get the information that we want. A tool that we used in, sorry, question first? Yep, I'll get to that when I talk about jQuery in a moment, but great question.
Yeah.
The question was about AJAX and callbacks, which we'll definitely talk about.
Yes.
So is JSON, is there like a function within AJAX?
So JSON itself, JavaScript object notation, is really just a way of representing data. It's not really a function in and of itself, though there are functions built into jQuery, which we'll talk about in a moment, that specifically are designed to interact with JSON data. But JSON itself stands for JavaScript Object Notation. It's a way of representing data using like the curly braces for surrounding keys and value pairs that you saw in the last problem set. So when you represent data as like open curly brace and then the name of the article, colon, here's the name of my news article, and the link for the article, colon, here's the link for the article. That was JavaScript object notation, just a way to represent data in a way so that you and I as humans can read the data and understand it, but more importantly so that a computer can take that information and understand, okay, I've got here a list of 5 articles, here are their names, and here are their links. So it's just a standard way of representing information that makes it easy for humans and computers to interact with it and understand it and interpret it.
Yeah, and it's a like standard way of formatting, just like Brian said. So because it's standard, a lot of like different like we can interact with this data that gets returned to us because we know that we're expecting JSON data. We know that how it's going to be formatted. So the part that it's standard is like also like important.
So jQuery was a JavaScript library. It's not a language in and of itself, but it's a library written in JavaScript that makes some things, writing some code in JavaScript a little bit easier. And so it was particularly helpful for handling AJAX requests. So the $sign was the symbol that was used to represent jQuery. And to make an AJAX request using jQuery, it was as simple as saying $.getJSON, where getJSON is a jQuery function whose purpose in life is to go to a particular route on a web server, get some data, and then do something with that data. And so this is where the idea of callbacks, in answer to your question, comes in. What we did with that getJSON function was to first say, okay, here's the route that I want to get the data from. Maybe it was /search or /articles, for example. And then, okay, here are the parameters that I want to pass into that particular route to say, okay, if I'm requesting articles, well, I want to request articles only for postal code 02138, for example. And then the final argument that the getJSON function took was the callback function, the function that was saying when this request is done, when the getJSON request is over and I've gotten the data from the server, what should I do with that data? And the answer was, let's use this callback function, and we'll call the callback function once the AJAX query is finished, once we've gotten the data back from the server. The result of that was such that we never blocked the user from doing anything. In particular, if you tried to type in like CAM into the search bar and the server was taking a long time to load or something because you had a slow internet connection, you could still click around and drag the map, for example. The website's still going to run. But when the data comes back from the server, when those locations that matched your search query come back, then the callback function gets executed. So the idea of the callback function is just that you tell your code that when this thing is done happening, when this query is done, when this request comes back, then I want you to call the callback function and then do something with the result of whatever data came back. So in the case of problem set 8, what you likely did was use the getJSON function to get your articles, to say, okay, get me all the articles that match this location. When those articles come back, you would use your callback function to say, this callback function will run once I've got these articles, and now I'm going to take those articles, format them nicely in a list of some sort, and then make that the contents of the information window.
Yeah, and in particular, if for some reason you were making a request to something that wasn't just like the articles for zip code 02138, but maybe images or something that has that takes like a longer time to be fetched from the server, and if you were debugging, you would notice that the line that actually makes the request, the getJSON line from the server, that gets executed, but you don't actually go within your anonymous function. So the anonymous function that gets called when the data gets returned, that doesn't get executed right at that moment. And if the data takes actually like a while to get returned to you, maybe like more than half a minute, maybe a minute, you'll notice that the next line of execution will be the line right after the implementation of the anonymous function. So that is sort of like to understand why you're not actually blocking the user from doing anything else is because your code continues running. The other lines like don't wait on that like anonymous function to be executed, but everything continues running. But when you actually get the data back to you and return to you, you actually go into your anonymous function and execute those lines of code.
Yeah, question?
Yeah.
So are callbacks just like a special event when the event is that like you got the data back?
So the question is, are callbacks just like a special kind of event? That's certainly a way to think about it. Usually when we're talking about events in JavaScript, we're talking about like things that the user did. User clicked a button, user hovered over this image, user submitted a form. But the callback function can oftentimes be associated with a particular event happening, you might think. So we might say that when data comes back from the server, then run the callback function. So if you want to think of it that way, you can. But generally speaking, we'll often use event to refer more to like things that the user is doing.
Yeah, essentially we're passing in this anonymous function as a parameter to the .getJSON call. So then when the server actually performs like all of lines of code that are associated with .getJSON, the last line of code that the server will perform in that function will be calling our function. So that's kind of how that messaging happens, is that the server calls our function essentially so that then when our function gets called, the lines get executed. That function gets executed.
Question over here?
Within the scope of what we know, is jQuery the only way to implement a callback?
So the question is jQuery the only way to implement a callback? It's not. There are ways to implement like JSON or AJAX requests that don't use jQuery. jQuery just simplifies the process, so we use jQuery to make the syntax a little bit nicer and more convenient to use.
Yes.
So is AJAX just like a concept built on JavaScript that, like, is this idea that you don't have to wait for this, that you can run everything else and then come back?
Yeah, so the question is AJAX like a concept built on JavaScript? Think of AJAX just as like the technique or the idea of saying, let's asynchronously get more information from the server. And functions like $.getJSON and jQuery are functions that use that AJAX technique in order to get additional data while the user is still on the web page.
Yes.
So would you want to like use that AJAX technique every time that you know that you're going to be getting data from like a different source, or would you just need to include that once inside your encryptor?
So the question was, would you need to use the AJAX technique every time that you are getting data from a different source, or just once in your program? It would actually be every single time if you're making requests for different things. Maybe you made a request for the articles and you're using this AJAX technique. If you wanted to make a request for images of each of those places, or of each of the articles that are associated with it, or something other that's distinct from the articles, like a separate request, you would again have to use the AJAX technique. So any single time that you're making a request for some data that's distinct from one another. Yes.
For JSONify and Python relations, like getJSON is JSONify, gives you the format of all that data, and then getJSON just pulling it from the function. Is that what it's in essence?
Yeah, so the question's about what JSONify in Python does. So JSONify is a function that's part of Flask. It's built so you do like from Flask import JSONify. And what the function does is it takes a Python list or a Python dictionary and takes that Python data and converts it into JSON format. So JSON, as we talked about, was a particularly very specific way of organizing and formatting data. And so when we call JSONify on a Python list or a Python dictionary, the result is that it gets turned into that nicely formatted JSON, such that a function like getJSON can read that data and understand what it means. Okay, great questions. Final thing we'll talk about are APIs. So APIs are application programming interfaces, and they're really a set of tools that are often built by other people that you can then use in order to add functionality to your own applications. So for example, in CS50 Finance, you didn't need to worry about how to actually go and get the price of a particular stock. We had an API for you, we had more than one API for you, whose purpose was to go and figure out what the current price of a particular stock was. And likewise for Mashup, you didn't need to worry about writing code that generated all the roads and lakes and rivers that display on a map, because Google Maps already did that for you, and they gave you an API that had parts of the API that were specifically for like displaying a marker or showing an info window associated with that marker. And so these were all features that were given to you as part of this API that you didn't need to write yourself, such that you were able to stand on the shoulders of others, so to speak, in order to use technologies that they had already built, use functionality that they had already built, and not need to reinvent the wheel per se, and just use what they had already done in order to add that functionality to a web application of your own. Anything to add there?
We have a question?
Question, yeah. Okay, so question was, what's the difference between an API and a library?
Good question.
Great question. Generally speaking, for our purposes, you can think of the libraries as like tools that you use in your code that sort of, what's the best way to phrase this? They help add functionality to simplify things that otherwise would have taken more code to write. So for example, we think of like jQuery as a JavaScript library because otherwise making AJAX calls to a different web server might have taken a lot more lines of code, and jQuery just simplifies it. APIs we'll generally use specifically as sort of technologies or services provided by other organizations. They give us access to some sort of information or that they have access to. So Google Maps gives us access to all of their location data, or Yahoo Finance or AlphaVantage gives us access to all of their stock data. And so we use their API to get data about those particular stocks, for instance.
Yeah. Any other lingering questions on week 9?
Questions about anything covered in the course so far? Whether it's the latter half or even earlier half, if you have questions about that too.
Yes.
So we were learning about like dynamic memory allocation in C and like
Great question. So the question's about, in C we learned that arrays have some, fixed length, and you can't make an array longer because whatever size you define it as, it's stuck there. Whereas in Python, when we have Python lists, we seem to be able to add to that list as much as we want, and we can continue to do that. So that's definitely true. So in terms of how those lists are actually designed, behind the scenes there's a lot going on there. Python is taking care of allocating new memory when it needs new memory to add more things to the list. It's taking care of figuring out where the different parts of the list should go and where all that memory is stored. And so you, in the end, don't need to worry about that because Python is taking care of figuring out how it works. But doing that comes at a cost. And in particular, it comes at like a time cost, where running code in C might generally be a lot faster than running equivalent code in Python, because Python needs to handle all of this behind-the-scenes stuff, whereas C is much closer to the machine. You are literally telling the machine what to do at any particular step in the process of your program, whereas in Python, we're a little more abstract. We say, add this thing to the list, whereas in actuality, what might be happening is that Python is having to allocate additional space for that extra element and then put the extra element there. You don't need to worry about any of that in Python. You don't have to worry about managing your own memory. So that makes it more convenient on part of the programmer, but also comes at a cost.
Yeah. Yes.
This kind of a syntactical question, but what exactly do the backticks and the dollar signs do in JavaScript?
Which is the first one?
Okay. Great question. So the question is, what do the backticks and the dollar signs do in JavaScript? That's just our way of plugging in values into a string. So if we have, similar to how in Python we had like formatted strings, where if we put like the letter F in front of a string and then put curly braces to say plug in this variable here, the backticks and the dollar signs are just JavaScript's way of doing the exact same thing. If you do a string in backticks and then have dollar sign followed by variable name here, that plugs in that variable name into a string. So different languages have different ways of doing the same thing. In JavaScript, it's that way. In Python, it's the formatted string way. In C, we use like %i and %s. They're all just different ways of saying, take this string and plug in some variable here, which has a value, just to substitute it in.
And as always, you don't need to worry about memorizing these things. They are readily available for you whenever you're not sure and would want to look up the syntax for how do you format a string in JavaScript. Yes?
For our CS50 finance, why do we have to start a lot of the methods with if request up method equals post? How do you know when you have to do that? We didn't have to do that in mashup. We had to do that in finance.
Yeah, so the question was, how did we know to start in CS50 Finance a lot of the functions that we wrote with the check whether the method was post or get? Yeah, so for example, let's take buy as an example. If you were to open your CS50 Finance web app and you clicked on the buy tab, that would be a GET request because you're not submitting a form on the page itself. So the GET request happens and you're actually trying to access that URL and go to the page. And for those purposes, we wanted to actually display a form for the user to fill in and to decide, to tell us like what kind of stock they want to buy and like how many shares they want to buy from that stock. In the other case, if like buy was accessed via post, via the post method, then we know that the user has actually pressed the button on that form, has pressed like buy. I want to buy like 3 shares of AAPL for Apple. So then we actually want to have some different functionality. We actually want to insert a number of different SQL statements, deducting from the user's total cash and adding to the transactions table to record this transaction. So what we did is we separated out the functionality that we wanted from the same URL, but based on the way that the user accessed this, the way that the user accessed the actual page itself.
Yep, great question. So the question is, what's the distinction between like server-side code and client-side code? So when you think about running your web application like CS50 Finance, like that application.py code for interacting with the database and processing everything that you were writing, that code has to be running somewhere. And so that's ultimately running on a web server, which is just some computer that's existing somewhere on the internet, such that when you go on your computer elsewhere and try and type in your website name and try and render the page, it's talking to that web server, that computer, in order to get information about what to display on the user's web browser. And so server-side code is any of the code that's actually running on that server. And so that server will generally have within it somehow connected a database such that it's able to talk to that database. So any of the code that's talking directly to the database, that's all most likely going to be code that's running in the server. And so if you think about examples of websites you use every day, like Facebook, for example, when I load like facebook.com on my computer isn't directly connected to Facebook's database. It can't directly look at all the posts that are stored in the database. Rather, Facebook servers are connected to Facebook's databases. So my computer has to talk to Facebook's server, which is running server-side code for processing my request and what I'm asking for, talking to Facebook's database to get information about all the photos and posts that I care about, and then sending that information back to my computer where it's then displayed for me. But any code that's actually running on my computer, which there might be some, like when I click on like someone's name in my messenger bar and like a chat box pops up, the popping up of the chat box, that's all stuff that's running on my computer probably. And so that's more than likely some kind of server or some client-side code running in my web browser that produces a certain behavior. And so that code doesn't require like necessarily talking to Facebook's web servers. But if I do type a message to someone and press enter, that's sending a message to someone over the internet. That probably does need to then go to Facebook servers and get processed that way. And so the distinction fundamentally is just that any code that only needs to happen on my computer is client-side code that runs inside my web browser. But any code that has to be run as part of like the application itself in your like application.py file, that's all going to be your server-side code.
Yeah.
I think JavaScript is client-side, right? But it still interacts with Python, which is server-side, via JSON and all that. So is it both, or?
Great question. So the question's about when we're writing JavaScript as like client-side code, we're still able to talk to like the web server. So how is that working? So the JavaScript code that we wrote is all client-side code. It's JavaScript that's running in the web browser on the user's computer, and that's not on the server. But what getJSON does is it lets us talk to the web server and make an additional request to that web server for additional information. And so when I typed in like a city into my search bar in Mashup, that caused in my client-side code the triggering of the .getJSON call, which sent a request to the server. Then the server-side code processes that request for the location that I typed in, gets the data from the database, sends that data back to my computer, where my client-side code then takes care of, okay, let's show the drop-down list, for example. And so that's an example of like client-side code and server-side code sort of interacting together. But generally speaking, the JavaScript code that we wrote in the last problem set, that's all client-side, whereas the Python code that we wrote in application.py, that's all server-side. But they can talk to each other.
And it is client-side because essentially it wouldn't make sense to try to run a lot of the like type of JavaScript code that we wrote on the server side, because there wouldn't be like a user interacting with that code just yet. So the server-side code that gets executed gives back information to you, and whenever you interact with your page, like on the client side, that page is responding dynamically and potentially, just like Brian mentioned, making additional requests to the server for some more information. But the client-side code isn't actually communicating directly with like the Facebook databases, just like Brian gave an example, and you don't exactly like know what like that code exactly does as well. So that's all on the server side. Yes.
So how exactly is JavaScript formatted inside of a .js file? So like I know Python is like a main function. How is like JavaScript written? Because it is also asynchronous, or how do you organize all of these functions?
Okay, you want to take that or? Okay.
doesn't
So the
matter.
question was
Yeah.
about how is JavaScript formatted inside of those .js files. And so you can take a look at like scripts.js from problem set 8 to get a sense for how it works. But generally speaking, the JavaScript code gets run from top to bottom. But oftentimes what we'll do is put things inside of functions. And so jQuery, for example, gives us this function called $document.ready. And if we do $document.ready and then provide some function, what that will do is say when the document finishes loading, when it's ready to go, it will run the contents of that function. And inside of that function, you can add whatever code you want, listeners for events, making additional AJAX requests if you want to, or whatever you want to include after your page is finished loading. So often we will put JavaScript code inside of functions and say, have this function run when the document finishes loading, or have this function run whenever this button is clicked. That way, the JavaScript code isn't triggered until something happens, whether it's the user clicking on a button or even just the page finishing loading, that causes that JavaScript code to actually run.
Yeah, typically your JavaScript code is going to be responsive to something happening. So you might want to do something once the page is fully loaded and actually maybe like display something else once you know that the page is fully loaded. That's when you would use what like Brian said is like document, like on document ready. I forget what the exact syntax is, but you're going to put code inside of a function that gets triggered when something happens, whether that's an event or another like sort of like type of like response, for example, from the server.
Okay, with that, we'll wrap up the review session. Staff will be sticking around after this if you have other more one-on-one questions that you'd like to ask us. But best of luck with your studying and preparation, and best of luck with the quiz.
Thank you all.